.NET Framework is a software framework developed by Microsoft that runs primarily on Microsoft Windows. It includes a large class library known as Framework Class Library and provides language interoperability across several programming languages. Programs written for .NET Framework execute in a software environment known as Common Language Runtime, an application virtual machine that provides services such as security, memory management, and exception handling. FCL and CLR together constitute .NET Framework. FCL provides user interface, data access, database connectivity, cryptography, web application development, numeric algorithms, and network communications. Programmers produce software by combining their own source code with .NET Framework and other libraries. .NET Framework is intended to be used by most new applications created for the Windows platform. Microsoft also produces an integrated development environment largely for .NET software called Visual Studio. .NET Framework started out as a proprietary framework, although the company worked to standardize the software stack almost immediately, even before its first release. Despite the standardization efforts, developers, particularly those in the free and open-source software communities, expressed their uneasiness with the selected terms and the prospects of any free and open-source implementation, especially with regard to software patents. Since then, Microsoft has changed .NET development to more closely follow a contemporary model of a community-developed software project, including issuing and update to its patent that promises to address the concerns. .NET Framework family also includes two versions for mobile or embedded device use. A reduced version of the framework, .NET Compact Framework, is available on Windows CE platforms, including Windows mobile devices such as smartphones. Additionally, .NET Micro Framework is targeted at severely resource-constrained devices. History. Microsoft started development of .NET Framework in the late 1990s, originally under the name of Next Generation Windows Services. By late 2000, the first beta versions of .NET 1.0 were released. In August 2000, Microsoft, Hewlett-Packard, and Intel worked to standardize Common Language Infrastructure and Soumyasch. By December 2001, both were ratified ECMA standards. ISO followed in April 2003. The current version of ISO standards are ISO IEC 23271-2012 and ISO IEC 23270-2006, while Microsoft and their partners hold patents for CLI and Soumyasch. ECMA and ISO require that all patents essential to implementation be made available under reasonable and non-discriminatory terms. In addition to meeting these terms, the companies have agreed to make the patents available royalty-free. However, this did not apply for the part of .NET Framework not covered by ECMA ISO standards, which included Windows Forms, Ado, .NET, and ASP.NET. Patents that Microsoft holds in these areas may have deterred non-Microsoft implementations of the full framework. On 3 October 2007, Microsoft announced that the source code for .NET Framework 3.5 libraries was to become available under the Microsoft Reference License. The source code repository became available online on 16 January 2008 and included BCL, ASP.NET, Ado, .NET, Windows Forms, WPF, and XML. Scott Guthrie of Microsoft promised that LINQ, WCF, and WF libraries were being added. On 12 November 2014, Microsoft announced .NET Core, in an effort to include cross-platform support for .NET. The source release of Microsoft's Core CLR implementation, source for the entire library stack for .NET Core, and the adoption of a conventional open-source development model under the stewardship of the .NET Foundation. Miguel Pericasa describes .NET Core as a redesigned version of .NET that is based on the simplified version of the class libraries. and Microsoft Simmer Landworth explained that .NET Core would be the foundation of all future .NET platforms. At the time of the announcement, the initial release of the .NET Core project had been seeded with a subset of the library's source code and coincided with the relicensing of Microsoft's existing .NET reference source away from the restrictions of the Mozilla SL. Landworth acknowledged the disadvantages of the previously selected shared source license, explaining that it made Codename Rota a non-starter as a community-developed open-source project because it did not meet the criteria of an OSI-approved license. Microsoft also produced an update to its patent grants, which further extends the scope beyond its previous pledges. Prior projects like Mono existed in a legal gray area because Microsoft's earlier grants applied only to the technology in covered specifications, including strictly the fourth editions each of ECMA 334 and ECMA 335. The new patent promise, however, places no ceiling on the specification version, and even extends to any .NET runtime technologies documented on MSDN that have not been formally specified by the ECMA group, if a project chooses to implement them. This permits Mono and other projects to maintain feature parity with modern .NET features that have been introduced since the fourth edition was published without being at risk of patent litigation over the implementation of those features. The new grant has maintained the restriction that any implementation must maintain minimum compliance with the mandatory parts of the CLI specification. Microsoft's press release highlights that the cross-platform commitment now allows for a fully open-source, modern server-side .NET stack. However, Microsoft does not plan to release the source for WPF or Windows Forms. Architecture. Common Language Infrastructure. Common Language Infrastructure provides a language-neutral platform for application development and execution, including functions for exception handling, garbage collection, security, and interoperability. By implementing the core aspects of .NET Framework within the scope of CLI, this functionality will not be tied to a single language but will be available across the many languages supported by the framework. Microsoft's implementation of CLI is Common Language Runtime. It serves as the execution engine of .NET Framework. All .NET programs execute under the supervision of CLI, guaranteeing certain properties and behaviors in the areas of memory management, security, and exception handling. For computer programs to run on CLI, they need to be compiled into Common Intermediate Language, as opposed to being compiled into machine code. Upon execution, an architecture-specific just-in-time compiler turns the kill code into machine code. To improve performance, however, .NET Framework comes with native image generator, which performs ahead-of-time compilation. Class library. .NET Framework includes a set of standard class libraries. The class library is organized in a hierarchy of namespaces. Most of the built-in APIs are part of either system, ** or Microsoft ** namespaces. These class libraries implement a large number of common functions, such as file reading and writing, graphic rendering, database interaction, and XML document manipulation, among others. .NET class libraries are available for all CLI-compliant languages. .NET Framework class library is divided into two parts: Base Class Library and Framework Class Library. BCL includes a small subset of the entire class library and is the core set of classes that serve as the basic API of CLR. Classes in Mescaler.dll and some classes in System.dll and System.core.dll are part of BCL. BCL classes are available in .NET Framework as well as its alternative implementations including .NET Compact Framework, Microsoft's Silverlight, and Mono. FCL is a superset of BCL and refers to the entire class library that ships with .NET Framework. It includes an expanded set of libraries, including Windows Forms, Ado, Net, ASP, Net, Language Integrated Query, Windows Presentation Foundation, Windows Communication Foundation, and Workflow Foundation. BCL is much larger in scope than standard libraries for languages like C++, and comparable in scope to standard libraries of Java. Assemblies compiled kill code is stored in CLI assemblies. As mandated by the specification, assemblies are stored in portable executable file format, common on Windows platform for all DLL and X files. Each assembly consists of one or more files, one of which must contain a manifest bearing the metadata for the assembly. The complete name of an assembly contains its simple text name, version number, culture, and public key token. Assemblies are considered equivalent if they share the same complete name, excluding the revision of the version number. A private key can also be used by the creator of the assembly for strong naming. The public key token identifies which private key an assembly is signed with. Only the creator of the key pair can sign assemblies that have the same strong name as a previous version assembly. Since the creator is in possession of the private key, strong naming is required to add assemblies to global assembly cache. Netcore is a free and open-source cross-platform implementation of the .NET framework. It consists of core CLR, a complete cross-platform runtime implementation of CLI, the virtual machine that manages the execution of .NET programs. Netcore also includes CoreFX, which is a partial fork of BCL and will support ASP.NET. Core CLR comes with an improved just-in-time compiler, called UJIT. Netcore runs console and ASP.NET software in Windows, Linux and OS X. It does not implement Windows Forms or WPF, which render the standard GUI for desktop software on Windows. As Netcore is designed to work with Universal Windows Platform instead. Netcore is also modular, meaning that instead of assemblies, developers deal with packages. C++, CLI. Microsoft introduced C++, CLI in Visual Studio 2005, which is a language and means of compiling Visual C++ programs to run within the .NET framework. Certain portions of the C++ program still run within an unmanaged Visual C++ runtime, while specially modified portions are translated into kill code and run with the .NET framework's CLR. Assemblies compiled using the C++ CLI compiler are known as mixed-mode assemblies, since they contain native and managed code within the same DLL. Such assemblies are also difficult to reverse engineer, since .NET decompilers such as NetReflector only reveal the managed code. Design principles. Interoperability. Because computer systems commonly require interaction between newer and older applications, .NET Framework provides means to access functionality implemented in newer and older programs that execute outside .NET environment. Access to COM components is provided in System, Runtime, Interop Services and System, Enterprise Services namespaces of the framework. Access to other functionality is achieved using the p-invoke feature. Language independence. .NET Framework introduces a common type system that defines all possible data types and programming constructs supported by CLR and how they may or may not interact with each other conforming to CLI specification. Because of this feature, .NET Framework supports the exchange of types and object instances between libraries and applications written using any conforming .NET language. Portability. While Microsoft has never implemented the full framework on any system except Microsoft Windows, it has engineered the framework to be platform agnostic, and cross-platform implementations are available for other operating systems. Microsoft submitted the specifications for CLI, Soumyasch, and C++ CLI to both ECMA and ISO, making them available as official standards. This makes it possible for third parties to create compatible implementations of the framework and its languages on other platforms. Security. Net framework has its own security mechanism with two general features: code access security, and validation and verification. CAS is based on evidence that is associated with a specific assembly. Typically, the evidence is the source of the assembly. CAS uses evidence to determine the permissions granted to the code. Other code can demand that calling code be granted a specified permission. The demand causes CLR to perform a call stack walk. Every assembly of each method in the call stack is checked for the required permission. If any assembly is not granted the permission, a security exception is thrown. Managed kilobyte code is easier to reverse engineer than native code, unless obfuscated. NetG compiler programs enable developers with no reverse engineering skills to view the source code behind unobfuscated net assemblies. In contrast, apps compiled to native machine code are much harder to reverse engineer, and source code is almost never produced successfully, mainly because of compiler optimizations and lack of reflection. One concern is over possible loss of trade secrets and the bypassing of license control mechanisms. To mitigate this, Microsoft has included .Obfuscator Community Edition with Visual Studio Net since 2002. Third-party obfuscation tools are also available from vendors such as VMware, VI Labs, Xenocode, and Redgate Software. Method-level encryption tools for netcode are available from vendors such as SafeNet. Memory management CLR frees the developer from the burden of managing memory. It handles memory management itself by detecting when memory can be safely freed. Instantiations of net types are allocated from the managed heap, a pool of memory managed by CLR, as long as there exists a reference to an object, which might be either a direct reference to an object or via a graph of objects. The object is considered to be in use. When there is no reference to an object, and it cannot be reached or used, it becomes garbage, eligible for collection. Net framework includes a garbage collector which runs periodically, on a separate thread from the application's thread, that enumerates all the unusable objects and reclaims the memory allocated to them. It is a non-deterministic, compacting, mark-and-sweep garbage collector. GC runs only when a certain amount of memory has been used or there is enough pressure for memory on the system. Since it is not guaranteed when the conditions to reclaim memory are reached, GC runs a non-deterministic. Each net application has a set of roots, which are pointers to objects on the managed heap. These include references to static objects and objects defined as local variables or method parameters currently in scope, as well as objects referred to by CPU registers. When GC runs, it pauses the application and then, for each object referred to in the root, it recursively enumerates all the objects reachable from the root objects and marks them as reachable. It uses CLI metadata and reflection to discover the objects encapsulated by an object, and then recursively walk them. It then enumerates all the objects on the heap using reflection. All objects not marked as reachable are garbage. This is the mark phase. Since the memory held by garbage is not of any consequence, it is considered free space. However, this leaves chunks of free space between objects which were initially contiguous. The objects are then compacted together to make used memory contiguous again. Any reference to an object invalidated by moving the object is updated by GC to reflect the new location. The application is resumed after the garbage collection is over. The latest version of Net Framework uses concurrent garbage collection along with user code, making pauses unnoticeable, because it is done in background. GC used by Net Framework is also generational. Objects are assigned a generation. Newly created objects belong to generation 0. The objects that survive a garbage collection are tagged as generation 1, and the generation 1 objects that survive another collection are generation 2 objects. Net Framework uses up to generation 2 objects. Higher generation objects are garbage collected less frequently than lower generation objects. This helps increase the efficiency of garbage collection, as older objects tend to have a longer lifetime than newer objects. Thus, by eliminating older objects from the scope of a collection run, fewer objects need to be checked and compacted. Simplified deployment. Net framework includes design features and tools which help manage the installation of computer software to ensure that it does not interfere with previously installed software, and that it conforms to security requirements. Performance. When an application is first launched, the .NET framework compiles the kill code into executable code using its just-in-time compiler, and caches the executable program into the .NET native image cache. Due to caching, the application launches faster for subsequent launches, although the first launch is usually slower. To increase speed of the first launch, developers may use the native image generator utility to manually compile and cache any .NET application ahead of time. The garbage collector, which is integrated into the environment, can introduce unanticipated delays of execution over which the developer has little direct control. In large applications, the number of objects that the garbage collector needs to deal with can become very large, which means it can take a very long time to visit and rearrange all of them. .NET Framework provides support for calling streaming SIMD extensions via managed code from April 2014 in Visual Studio 2013 Update 2. However, Mono has provided support for SIMD extensions as a version 2.2 within the Mono SIMD namespace. Before, Mono's lead developer Miguel Torrecasa has expressed hope that this SIMD support will be adopted by CLR's ECMA standard. Streaming SIMD extensions have been available in x86 CPUs since the introduction of the Pentium III. Some other architectures such as ARM and MIPS also have SIMD extensions. In case the CPU lacks support for those extensions, the instructions are simulated in software. Licensing. Components of .NET Framework are licensed as follows.